Homogeneous system of linear equations. Suppose A is the coefficient matrix which has an order m cross n, and we have a column vector x which contains n number of variables. Then the system defined as Ax equals to 0 is called the homogeneous system of linear equations. If the right hand side where this 0 is actually the column 0, if it is non-zero, then it is a non-homogeneous system of linear equations. We'll try to understand here what are the cases when it will have solution, when it will have trivial solution and non-trivial solution. The very interesting thing about homogeneous system of linear equation is it always possesses a solution. For example, in this case, if I choose x equals to 0, then it satisfies the system. So x equals to 0 is always a solution of homogeneous system of linear equations, and this solution is called the trivial solution. Now we'll take cases when we can have a non-trivial solution, means we can have a solution where x is not equal to 0. So we'll define case by case. Suppose m is less than n. So in that case, rank of A will be equal to, or in general we can write it is less than n. As we know from the consistency of the system of linear equation, a system will be consistent in only case when rank of the coefficient matrix is equal to rank of the augmented matrix. But here in this case where B is already 0, so the rank of the coefficient matrix and augmented matrix, they will be always same. So that is why the system is always consistent. So instead of comparing the ranks of the coefficient and the augmented matrix, we'll only focus on the rank of the coefficient matrix, because it is always same. Whatever the rank of the coefficient matrix is, same is for the augmented matrix. So we are taking the first case where m is less than n, then definitely rank of A will be less than n. And in this case, this is the case where in the case of non-homogeneous system of linear equation, we had a multiple solutions. So in this case again we will have a multiple solution. X equal to 0 is one of the solution which is always here, and apart from x equals to 0 we'll get x which is non-zero, and it will also satisfy Ax equals to 0. So this is the case where we'll have a non-trivial solution. Second case, when m is equal to n. So it will have two sub cases. If m is equal to n, then rank of A. Say here if m is equal to n, then definitely A is a square matrix. So if rank of A is equal to n, then A will become a square matrix and it will be an invertible matrix because its rank is equal to its order. So in that case, Ax equals to 0, we can simply solve it x equals to A inverse 0, which is resulting only x equals to 0. So if rank of A is equal to n in this case, then it will have only trivial solution. Trivial solution only. The other case in this particular scenario, rank of A may be less than n. In that case, it will follow the previous clause 1. In that case, it will have non-trivial solutions. See, trivial is always there. The only thing is, in some cases we are expecting non-trivial solutions. The third case arises here when m is greater than n. In that case, what we can do, we can use the elementary row operations and we can convert this case into either the case 1 or the case 2. Now we'll take an example where we'll solve a system of linear equation and we'll see its solution. So let us take a homogeneous system of linear equation. It has x minus y minus z plus 3r equals to 0, x plus y minus 2z plus r equals to 0, 4x minus 2y plus 4z plus r equals to 0. So this is our given homogeneous system of linear equations. It has 4 variables x, y, z and r, and there are 3 equations. So clearly here m is 3 and n is 4. So definitely it is going to have non-trivial solution. So that solution we need to check because its rank is going to be less than n, the rank of the coefficient matrix. So to get that non-trivial solution, we'll follow the procedure of row reduced echelon form. So let us write its coefficient matrix A in this case. So it is going to be 1 1 4 minus 1 1 minus 2 minus 1 minus 2 4 3 1 1. Let us convert this matrix into its echelon form. So I am keeping the first row as it is, 1 minus 1 minus 1 3, and for row 2 I am using the fundamental row operation. R2 is being replaced by R1 minus R2. So this is going to be 1 minus 1 0 minus 1 minus 1 minus 2 1 minus 1 plus 2 1 3 minus 1 2. For R3 I am using the row operation 4 R1 minus R3. So 4 minus 1 4 0 minus 4 plus 2 minus 2 and minus 4 minus 8 and 12 minus 1 11. We'll go for one more round of fundamental row operations. 1 minus 1 minus 1 3 0 minus 2 1 2, and for R3 we can simply choose the row operation R2 minus R3. So 0 minus 2 minus 2 0 1 minus 8 9 and 2 minus 11 minus 9. So this is the row reduced echelon form of the initial coefficient matrix A. Now let us again turn this matrix into system of linear equation. So it is going to be x minus y minus z plus 3r equals to 0, minus 2y plus z plus 2r equals to 0, and 9z minus 9r equals to 0. So see here, it has got 3 equations and 4 unknowns. So to have the solution of this system of linear equation, we need to set one of the solution, and then rest of the solutions will dependent on that chosen particular solution. So it's like a rule, number of variables minus number of equations, they are going to be the total number of independent solutions. Again I'm repeating this, number of variables minus number of equations, this will turn out to be the number of independent solutions. So here the number of variables are 4 and number of equations are 3. So 4 minus 3 equals to 1 is the number of independent solution, and this solution may be any one, either x, y, z or r. So let us say r is the independent solution. I am choosing the value of r as c. So we'll get the value of z equals to, from the third equation, c. And if we put the values of r and z into the second and third equation, we'll get the value of y as 3 by 2c and the value of x will be minus 1 by 2c. So here you try to understand the meaning of independent and dependent solution. Once we declared that the r is the independent solution, it may have any real value, say c, and now rest of the solutions z, y and x, they are depending on the solution value of r. So the value of z is c, the value of y is 3 by 2 times c, the value of x is minus 1 by 2 times c. So this solution in a vector form can be written as x, y, z, r. This is equal to, we can write minus 1 by 2c, 3 by 2c, c and c. If I take c common, so it is going to be minus 1 by 2, 3 by 2 and 1 and 1. So see here, this is the meaning of non-trivial solutions, and since the rank was less than n in the initial coefficient matrix, so it is going to have the infinitely many solutions. So here c belongs to set of real numbers. You keep on choosing the values of c, you will get the different solutions of this system.